in section 4.2, we're going to talk about a couple of methods, and we're going to focus on just one of those methods on how we can solve other types of triangles. And so this section is called the law of sines. The other type of triangles that we want to solve in addition to solving right triangles are called oblique triangles. And basically oblique triangles are, I guess this might not be a proper term, but non-right triangles. So any triangle that is not a right triangle is called, we're going to call an oblique triangle. That's our definition for oblique triangle. And so there's a couple of different ways that we can obtain or have oblique triangles. One case is where all three of the angles in the triangle are acute. All right. And the other case is where we have an obtuse angle and two acute angles. All right, remember the sum of your interior angles in a triangle is equal to 180 degrees. So we can have three acute angles, or we can have one obtuse. Remember, obtuse means bigger than 90. And if one is bigger than 90, the other two have to be less than 90 and to make that a true triangle. All right. There are basically two methods that we can use to solve oblique triangles. One is called the law of sines, which we're going to talk about in this section. And in the next section, we're going to talk about the law of, you probably could guess it, cosines. Okay. And so similarly to how we solve the right triangles in the previous section, we can use this method. Like if I give you two or three pieces of information, you should be able to use that information and the fact that you have an oblique triangle in order to help you in solve those triangles with these methods here. So let's look at the law of sines a little bit more clearly. All right, so the law of sines, it says for a triangle with sides A, B, and C, notice that our side lengths are lowercased, and opposite angles, A, B, and C respectively, then the law of sines states that sine of angle A divided by sine length A equals the sine of angle B divided by sine length B, and that equals the sine of angle C divided by side length C, right? And so as long as we do the ratio of the sine of the angle over the side length of the opposite side of that angle, then we have a true proportion, right? A proportion is an equation that relates or equates to ratios. There are certain things that we need in order for us to be able to use the law of sines. For instance, if I just look at this proportion here, in order for me to solve or find a side length that's missing, I've got to have at least three pieces. For instance, I can only use the law of sines if I know, for instance, measure of angle A, side length A, and let's say side length B. All right. By knowing those three things, then I have enough information for me to be able to find that missing piece right there. Or I can know B, and one of the A's, and then I can use this law of sines in order to help me find the other A that I'm missing, right? And so there are some special cases that the law of sine is only going to work for. And these are the cases here. Case one is sort of two scenarios. We have this ASA means angle, side, angle. And notice here the side is in between the two angles, as I can see in this picture here. I can use the law of sines here because, well, I know two angles, and this side we call the included side because it's between the two angles that we know. But I could use my law of sines because if I know these two angles here, I really know this angle here because I know the sum of my angles is 180 degrees. And so I have a side and its opposite angle, so kind of like knowing A and little a. And then now I can find B and C by using something like this. Okay? Same thing happens when we have a side that's not included. So here, angle, side, angle. So we know two sides and the included angle. Sorry, two angles and the included side. Here we know two angles and the non-included. This is not included side, right? And as you can see again, I know an angle and the opposite side, which gives me a full piece of the ratio that I need, right? And I know another angle, and I can use my fact that my sum of my interior angles is 180 degrees to get that angle. And so I'll have enough information for me to find my sides. All right. So this is case one. All right. Although they're different, they're case one because these always result in one triangle or one solution. Case two is a scenario where I only have one angle and two sides, and it's specifically two sides and a non-included angle. I can use it, right? Because I do have my opposite angle and an opposite side, but I don't have two angles here. And whenever I have a case when I don't have two angles, and I don't know whether that angle is acute or obtuse, I may end up with one or two triangles. And what we're going to see is that in this case, it can be in such a way that we can have zero triangles as well. Now, in this video, we may not see a case like this, but by the time we get through this in our course, we'll be able to see examples where we have 0, 1, or 2 triangles when we have case 2 with side-side angle. Let's look at one example. All right, here it says solve the following triangle if possible, and we're going to round our answer to 2 decimal places. Okay. Notice here that I don't know that this is a right triangle because angle C doesn't have a square there. And in fact, these two angles here look to be bigger than 90 degrees, so I can go ahead and say that this is not a right triangle. So I know I have an oblique triangle. So what I'm going to do is I'm going to try to find my other pieces. The easiest piece for me to find first is angle C. So I'm going to find angle C. We know for a fact that our total angles measures add up to 180 degrees. So if I subtract off my two given interior angles, I'll see that the measure of angle C is 180 minus 54 minus 48 is 78 degrees. And so I know that one there. Now let's find side length, let's say B. Well, for me to find side length B, I'm going to use the fact that angle B measures 54 degrees. And I know the information regarding angle A and side length A. Okay? And so if I cross multiply, and then I divide both sides by sine of 48 degrees, the exact value of side length B is 12.5 times 54 degrees divided by sine of 48 degrees. All right, now I'm going to pause